Very good. Thank you very much. So it's my pleasure to introduce our next speaker, Alexander Kagoshima. He works as a data scientist at Pivotal, and he's going to be talking to us about a data science operationalization framework. And I believe it has something to do with open source as well. Is that right?
It does.
Okay,
it's on GitHub.
Very good.
Yeah, thanks, Valentin. So, yeah, my name is Alex Kagoshima. I work as a data scientist at Pivotal, as Valentin said. And what Pivotal does is, on the one side, we have a couple of big data platforms. We have a open source PaaS platform for deploying applications. And the third thing we do is kind of app development and data science, which is also the part of the company I am in. And what I do as a data scientist at Pivotal is I don't work on Pivotal's internal data. I help customers who buy our big data platform to kind of realize use cases, to gather value out of their data. They put their data on our platform, which we put on their premises, and then I go in and develop some models on top of it that then show what we can basically do with big data. So that is my job. And so I put PowerPoint in this view because otherwise the ends, they get cut off. So what we do in our engagements, one big thing that might not be typical for all data scientists, but it's definitely true for data scientists which kind of work on one-off projects, kind of limited projects at one customer, is that we often go into a customer and the customer has really a lot of data sources. He has like a dozen Oracle databases, then there's an SAP system that uses that as a backend. There's, I don't know, MySQL, there's Postgres, there's loads of siloed data sources. We work mostly with enterprise customers, so that's especially true if you have a company with, I don't know, 200,000 employees. And they also have siloed systems. And they kind of have this very, very complicated landscape where they run their business off. And to me, it's often a miracle that this works. But apparently it does. And when we go in, we say, okay, what do you want to do? Okay, you want to, I don't know, you want to analyze the GPS data that your fleet is collecting or something. Then we say, okay, we need all your GPS data. Then we do this big data extract and we pull all of that and put it in some kind of distributed big data platform, which nowadays is mostly Hadoop. Could also be something different. And within the distributed big data platform, I do my job. I work on that data extract. I develop models on top of it, analyzing all this historical data, gathering intelligence out of it. And then my model, it lives here. What I then also do is I create some kind of, oh, that's not good. I create a fancy PowerPoint mostly, showing the results of my model, showing what it can do to the business. That's, I don't want to say that's it, but in reality it is mostly. So we also often say models go to PowerPoint to die. So so the model really lives here, and it's if we are really honest to ourselves, it's a bunch of scripts. It's not a really cool application that is easily that someone else can run. You usually need the guy who coded it to run the model, and that's not good, because when we have that situation, the big question is, how do we come back here? How do we do this? Because the business is run off this landscape, right? So all the business decision, I don't know, the Excel reporting sheets that the manager sees, they are pulled from these systems. And having all of this here, then nobody really can do anything with the stuff we did. The interesting thing is also, if you look at all the big data frameworks for analyzing data, Spark or Flink, for example, or I don't know what, MapReduce 2 years ago. They're really good at solving the problem here. So they're really good at taking a big amount of data and then extracting something out of it. They're really good at doing all of that here, but there's no real principled way of getting the results back here. So I think this is a really big problem that we as data scientists really should work on. So otherwise we are stuck in the hype cycle, and then everybody will say, no, data scientists, we can't deliver. So we really, in my mind, as data scientists, we really need to work on being better at transporting our models to the business. Yeah, so these are the points that I already mentioned. So we have really scripting instead of production-ready models. If you look at me, I have like a dozen IPython notebooks, and then I create some scripts out of it, and then I know the order of the scripts which they should be run in. Then I put numbers in front of the scripts to make it look easy, but in reality it's not. So that means if I want to hand that over, I really need to train the people, and I don't know if they remember what I told them. It's really not a reliable way in my mind. It also takes pretty long to actually get this platform up and running. So that's especially true in our case, because when we work with enterprise customers, what we tell them or what they want is they really want something on-premise. So something like Amazon or something where they need to put their data outside of their premises, they don't want to do that. So that is especially true to us. Long setup times. It's bad to encapsulate our work for others to reuse, and operationalization. How do you actually do this? So what do we need to actually try it differently? So what we really want to have is an easy way to actually operationalize models, to kind of attach our models to existing legacy systems. Which would really need to be some kind of interface, right? Some kind of API. When we as data scientists, when we do our modeling, it's also often the case that we might choose the more fancy algorithm that is really mathematically elegant, and maybe not the simple one that just gets the job done, right? And maybe the simple one, in my experience, is often easier to operationalize. So I think as data scientists, we really need to start to think about operationalization from the beginning. So what I did in this special case is I leveraged Cloud Foundry, which is our open source PaaS, to spin up environments quickly. But I will get into that more later. So what I did, having all of these problems in mind and wanting to do something about this, is I created a small operationalization framework, as I call it. So you can think about it as exposing an API. So it uses Flask to do that, basically. So I have some routes defined in Flask where you can kind of ingest data. So you can send data to that framework as a JSON, and it sends results back as a JSON. What I did just to get running quickly is use Redis as a model and storage backend. So whenever I create a model within this framework, it all gets stored into Redis. And also the data gets stored into Redis. Which is, to be honest, it's not really scalable yet. So it's Redis is very fast, which is good, but it's not really made for big amounts of data. So what you would actually want to have is a true big data store like Hadoop. I implemented two models just to show how it works. Linear regression and online linear regression. And the cool thing is, so it's deployable to Cloud Foundry. So about Cloud Foundry, who knows what Heroku is? Okay. So you can think of Cloud Foundry as Heroku, but you can set up your own Heroku. Okay? Heroku just has one instance that sits somewhere in the cloud where you then push your apps to, but Cloud Foundry means you can set up your own paths on your own cluster, okay? And then you can use that, which is really cool for enterprises because, again, enterprises, they are paranoid. They don't want to use the cloud, especially in Germany. So they really like this. It's open source. You can check out the website. And this is kind of the Heroku instance of Cloud Foundry, okay? Here you can sign up and then you can push applications there. And the framework that I'm going to show you in a second is actually also deployed there. Yeah, so it's basically it's the idea of a path. So you can push applications there and make them run there quickly and leave all of the hassle with database setup and so on aside. So this is actually what the framework looks like. So from this you can probably understand a little bit better what I'm talking about all the time. So you have this API which you can talk to. You send JSON there, so you send a JSON request that says create me a model. And what it does then, somewhere here in the backend, it creates a model and stores that in Redis. And then you can say, okay, send data to that model as a JSON. Then the API will ingest that data and kick off a retraining. So a periodic retraining probably because usually not on every data point you need to have some kind of retraining, right? But it does this automatically. So you start sending it data and then it kicks off the retraining and then saves the model into Redis. And there's also some visualization thing which I did, which I will also show you in a little bit. So it's actually deployed here. So if you go here, you come onto the landing page, which is just the README markdown that you also see on GitHub. So if you want to get the code, it's here. And the idea of this is really to have some kind of encapsulated model. So you don't have a model anymore that is basically a bunch of scripts that sits somewhere on a big data platform and is really hard to operationalize. This is really an API that makes it easy to attach other parts of software to it. And with this, I think we can do some demoing. Oh, that's really hard to read, right? So here, that's Redis. Redis is awesome, by the way. You just install it, say Redis server, and boom, it's there. It's really cool. This is where I start the framework. So I'm running it now locally, but you can just push it to Heroku or Cloud Foundry, and then it will run there the same way. And what I'm going to do now, a good idea might be to first go onto the web page just to show you what it looks like. So this is basically what you see when you get there first, and it kind of tells you how to operate it. So to create a model, oh, that's really hard to read, I guess. To create a model, you do this curl request, and this is the actual data that you're sending. So you say, okay, this model has a name. You specify a type of the model, which you would need to implement before, and then you give it this retrain counter, which says, okay, every 10 new data points, I actually want to do some retraining. So let's create a model of this kind. So here I'm sending it the JSON request. How do I make this font bigger? That works. So once I send it this request, it says created model. Can you read that? Even bigger. come on, you can read that. So that says created model, retrain counter, available data, it's not trained, it's a model of this kind, it doesn't have any training data that is used, and it's called model 1. Sorry? I have no idea what you're talking about. Oh, I'm sorry about that. I'm not doing that. Just come to me later. I will show you. So what was I doing now? So now we have created the model. What we want to do now is send it data, and let's maybe take a look at it here first. So the way that you send the data, this is also the way you send it with curl. And this is the data that you're sending. So this is a JSON. Okay. So you send it the model name. And so instead of calling it X and Y, I just called it input and label. So label is always the thing that is the model kind of that's the dependent variable that the model needs to learn, and this is the input. So if you look at this input and label thing, so and you know it's a linear regression, what kind of function is this learning? Y equals X, exactly. No, f of X equals Y, yeah. Okay, so we are going to send that data into the model then. Oh, there's another thing I can show. So basically what you can also do is you can go to models. And here, so this is a really basic view. So you have you have this model 1, and then you can also go into model 1, and then it tells you the current state of the model. But now let's send some data into the model. Okay, so here it's 10, it's 9, it's 8, so we send 10 data points into the model. And then if we go to this view again, then you can see, okay, it's trained now, since we sent 10 data points in. And the parameters it learned are input 1 for input, and it has a 0 constant. So it learned the right function. Okay, so that's basically the very basic view of what it can do, which is not really exciting. So I created a visualization that looks a little bit better. So what I'm doing here is, this is some simulator that sends data into the model all the time. And I can visualize this like this. So what you see here is the last 100 data points that were sent in. And you can see always new data points coming in. And the data points are generated by basically a linear function with some noise added to it. And then the blue line that is wiggling around, that is the trained model that it's learning. So, but what can happen if you were training a model is, it can happen that the behavior changes, the underlying behavior. So that's what I'm doing here. So basically you can see the underlying data that the model sees is changing, and you can see the model adapting to that. So this is the online linear regression part of it. So this is a really basic example, I know. But I actually really like this visualization. I showed this to a couple non-technical people, and they were very unimpressed. they said, "What is this? This is just points, and this is a line. It wiggles around, and it doesn't tell them anything." But I think if you know some stuff about machine learning, so it's a model and it learns something. Okay, this is something that's cool. Yeah. So that's basically all this is doing. Okay. And the other cool part of it is also that you can deploy it on a path. So yeah, once you have this this API, it provides a simple way to expose it to other parts of software. You could think about if you have a web application, you could send some stream to a framework like this, and you need some kind of prediction, and then it sends you some data back. What you could also do with a framework like this, as a data scientist, there's some tedious work you have to do. So if you're working on a problem and you have this data set and you create different kinds of features and you have different kinds of models, then what you actually need to do is you really need to keep track of everything you're doing, right? You need to keep track of all the different feature engineering variants, of all the different model variants that you have. And you need to keep track of all the results, so you know at the end what was the best thing you did. And you could think about integrating some visualization layer there that you can access by the browser, which then tells you, which keeps track of everything for you. So you could use something like this to free yourself of really tedious work and just focus on the feature engineering and the modeling. You could also think about creating different model instances via the API. Let's say you have different classes of data in your stream. And you can easily use standard machine learning models that you have. And once you created a model with this, it's really easy to reuse. But the requirement is really you need a live feed of the data, which at least for us as kind of consulting data scientists is a little bit hard to get. But we are getting there. This is also really hard to read, right? So this is showing how you would implement the model. So this is the linear regression model. And what you can see here is that it implements a model interface, and that model interface tells you that you need to implement these three functions: range, score, and parameters. So all you need to do if you want to create a new model within this framework is implement a class like this. And if you want to look at the code, this is the GitHub address. So if you want to expand the model like this, I think you could actually expand a framework like this to actually work in this enterprise landscape. You have this basic API where some stuff happens in the back end. You would need some additional modules, like a data ingest module, for example, that maybe does some pre-processing. You would probably need something like a cleaning and a transformation module that helps you to also to pre-process the data and maybe aggregate the data a little bit. And what you would also need is a proper big data store. Right now it's storing everything in Redis, which is, as I said, not really scalable. And so one cool thing about paths is that you could also think about getting some kind of data exploration module in there. So think about what we do as data scientists. So oftentimes we get the data onto our local machine, and on our local machine we really have a bunch of tools. We have, I don't know, pandas on there, scikit-learn, matplotlib, and then we do our stuff there. And then it sometimes happens, oh, I need this thing as well, then you need to install it first and so on. But what about if you had this image set up for you, this container that already contains all of this, and if you do your work, you just log onto this, this container or machine that is hooked up here, and then you already have everything in here. And then you can access the data. So this is just some wild idea that I had. And another important part is that what you also usually have, you usually don't start from a green field where you have no data at all. Usually you have this big data extract already. And you would also need something that doesn't only receive data, but also receive a data reference. So something that says, okay, the data sits in Hadoop in this path, and it's of this file format. So this is something that you would need to work towards if you really want to use that in an enterprise environment. So this is just really a tiny thing that I put together in a few days based on my observations that I gathered during my work. And there's really a couple of open questions that you need to answer before you use forward. For example, does it make sense to have the training and the scoring on the same machine? Or would it make more sense to split that out and have one thing that only does the training and one thing that only does the scoring? If you want to be really scalable, this would probably need to happen. The ability that you can actually push that thing onto a path gives you immediate access to automatic scaling. So let's say you have your website suddenly gets 10 times more users, you just scale the containers that you put there up. But how exactly that is used is kind of open. You could also spin up multiple instances. Then there's the question that I mentioned about feature transformation and feature engineering. Also, is it possible to use the same data transformation process on the incoming streaming data and on the training data that's already there? There's also the case where you have feature generators that only work in batches. Where you need to aggregate some data. That also wouldn't work with this kind of framework, but would be something that you would need to think about. And if you actually send scoring data to that framework all the time, you would also need a way to add a label to that data later, probably. So there's really still, this is just a tiny little prototype framework that I did, and there's these lots of open questions that you would need to answer if you want to move this forward. So I am not the first one who thought about this. There's a couple of similar stuff, which is very interesting. So there's vlogs, which is, it seems like it's in very infant stages, but it's from the AMP lab. Those are the guys who developed Spark. There's the Google Prediction API. And there's Prediction.io. So Prediction.io, I would say, is the most similar thing to what I did. If you use something like the Google Prediction API, you're basically stuck with Google. So Google then eats up all your data, and you can only do it on Google's premises. So if you have a framework like this, you can also deploy it on your own premises, right? Which is not the case with Google. Okay. So with these pointers, I'm basically done and open for any questions.
The audience?
Yeah, it would be nice. Could you give us just a real-life example of what you did and where this could be an applicable model maybe for the next time you do it again?
So one interesting data science engagement that I worked on recently was detecting malware communication within proxy logs. And one of the models we created was just analyzing the domain name. So there's malware which communicates to these randomly generated strings. And that's a use case where you could perfectly use this kind of framework, because all that you need is you send in these domain names all the time, and then you would get a score back. So this is a real, because this is such a simple model, it just scores one domain name based on some natural language processing. You could actually do it in this kind of, in this version of the framework. But that being said, for a lot of more complicated use cases where you need to aggregate the data first in some way, then you would need to do some more work.
Okay. Any more questions?
Hi, in the API example, I saw that you're sending your example and the label directly to a model. So wouldn't it make sense to decouple this? Because typically when you do this, you use the data with many different models, especially when you do exploration. So I think having a data entity and the models, and then basically what you're interested in is applying this part of data to that particular model. So there's a many-to-many relationship here in the end.
Yeah, definitely. You could do that. I invite you to pull the code from GitHub and do that.
Okay,
no, but that's a cool idea.
Perhaps time for one more question. All right, if there's no more questions, let's thank the speaker once again.
Thank you.